Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem 2467, most profitable path in a tree. This question has been asked in Amazon, Intuit and Google, and I will rate this question from medium to hard. But don't worry about the problem statement. It's a lengthy problem, but I will try to make it easy for you. And it is based out of tree, graph and DFS. So you should be having some understanding of recursion. If we just try to have a quick look on the problem statement, they are playing some kind of game, and in this game there is an undirected tree of n nodes. Nodes are from 0 to n-1, and root node is 0, and you are given a 2D integer array edges, where edges are the edges between those nodes. So let's say if value of n is equal to 5, we are going to have nodes from 1 to 4, 0 to 4. Okay, and edges are something like this, from 1 to 2. So there is an edge from 1 to 2, undirected edge. It means 1 is connected to 2 and 2 is connected to 1. Okay, every node I is a gate. You consider it as a gate, and you are also given an array of integer amount, and the amount I represents the price needed. If the amount is negative, it is the price needed to open the gate. Otherwise it will be considered as a reward. Let's say if amount is -4 will be used to open the gate. If it is 6, let's say 6 or 2, then 2 will be added to our rewards. Okay, so this is some kind of stuff, and now the game starts. Initially Alice is at node 0 and Bob is at node Bob. So two nodes are also given to us. Alice is at 0 and Bob is at Bob. At every second, Alice and Bob each move to the adjacent node. Alice moves towards the leaf node and Bob moves towards the node 0. Every node along the path, Alice and Bob either spend money to open the gate or accept the reward. Note that if the gate is already open, no prize will be rewarded and no cash will be received. If Alice and Bob reach the same node simultaneously, they will just divide everything. Whether it is like -4, then they will just divide -2 and -2. And if it is a reward, let's say 6, then they will divide 3 and 3. If Alice reaches the leaf node, then she stops moving. Similarly, Bob reaches the node 0, then he stops moving. Okay, so Alice is reaching towards leaf node, Bob is reaching towards 0 node, and these events are independent of each other. Okay, there is no mixing between these two events, and in the end return the net income Alice can have if she travels towards the optimal leaf node. Okay, now forget about the problem statement. Let's just have a look on what is given to us. Given is number of edges in the tree, or you can say graph. Here edges dot length is n-1. If we are having n nodes and we are having n-1 edges, it is a tree. n-1 is the minimum number of edges required to connect those nodes. So okay, so in this case these are the edges 1, 2, 3, 4. It means we are having 5 number of nodes starting from 0 till 4, and these are the edges. And along with that they are also given this Bob node. Bob node is something, Bob is starting his path from this node and Alice is starting at 0. See, there are two actors in our game, Alice and Bob. Alice is doing something like starting at 0 and Bob is starting at Bob number of node, and there is amount associated with every single node. So nodes are from 0 to 4. See, to make it very simple, let me just draw these edges. These edges are from 0 to 1. Let's say 0 node to 1 node, and 1 node to 2 node, and 1 node to 3 node, and 3 node to 4 node. See, this is my tree, or you can say graph. This is my graph with n-1 number of nodes, number of edges. Okay, so in this graph the Alice is going to start his path from node 0, and Bob is going to start his path from node Bob. In this case, Bob is 3, so Bob is going to start his path from Bob. And then they are saying that if Alice has to start at 0 and going till leaf node, starting from 0 to leaf. So if we just have a look on the leaf nodes, how many leaf nodes are there? See, Alice is starting from 0. So let's not consider 0 as a leaf node. Apart from 0, this is one leaf, this is second leaf. So Alice can cover this path as well, or this path is another option. So Alice can go through these paths in this case, and both the paths are leading towards leaf. So Alice is going to cover 0 to leaf path, and Bob is going to cover Bob to 0, node 0, which is my root of the tree. Okay, so Bob is going to start from 3 and going till A. So it means there should only be one path, because Bob node is fixed, 0 is already fixed, right? 3 to 0. And leaf node we can have multiple possibilities, so that we can have multiple path. One path is from 0 to 4, and the second path is from 0 to 2. So these things are given to us. So now what else? This tree is given to us, and then edges are given. See, edges are of no use. At least we have to prepare a tree. If we have to prepare a tree, or in this case I can call this tree a graph. If we have to prepare a graph, you already know that how do we maintain a graph. We maintain any graph using adjacency list or adjacency matrix. See, this is the representation, like to store a graph. Bob is starting at 3 and Alice is starting at 0, and from 0 to leaf. See, what we have to return is Alice is starting at 0 and Alice is going to leaf. So Alice should capture the maximum income. Okay, so you can say maximum score, maximum rewards that Alice is going to have. So she is starting from 0 node and going till leaf node, and she want to capture the maximum income, maximum score. So how does she do? She can start from node 0 and she can do the DFS, or you can say the direct traversal from 0, check every path. But see, in this case this graph is undirected graph. Like unlike other graphs, this is not having any direction. It is a graph, so whenever we are iterating over the graph, we need to take care of the visited array as well. So see, for now, if you are getting confused, just forget about this Bob and just focus on the Alice. And what we have to figure out is Alice is going to cover a path from 0 to leaf, and she want to get the maximum score from root to leaf, maximum path sum from root to leaf. So this is the question. And now in this case, what we have to do is, like, first of all we need to prepare an adjacency list. So first step in this problem, to tackle this problem, will be preparing adjacency. In case you are not aware of the adjacency list or matrix, let me tell you, adjacency is something, how do we store the graph. Graph is something, there are two nodes and those nodes are connected. U is connected to V. So we have to store all of these pairs, or you can say edges. In this case, they are saying that there is one undirected edge from between 0 to 1. It means 0 is connected to 1. 0 is U here, 1 is V here. But 1 is also connected to 0. So there are two options. So in this case, 0, 1, 1, 2, 1, 3, 3, 4. If I just take the edges and try to prepare the adjacency out of it. It will look something like this. If I prepare the adjacency, I am already aware that number of edges are 5. Number of nodes are 5. Why? Because number of edges are n-1, and it's already given that number of nodes are from 0 to n-1 index. So okay, if it is 5, why not we just take an array of 5? Array index 0, index 1, index 2, index 3, index 4, and every index is going to have a list of all the neighbors, list of all the nodes it is attached. See, if it just take a first edge, 0 is connected to 1 and 1 is connected to 0. 0 is having an edge towards 1 and 1 is having an edge towards 0. So this is the significance of undirected graph. U to be undirectional edge. So if it is a directional edge, I will just only store it once in the adjacency. It's a very easy things, common things in the graph theory. I'm just telling you in case you are not aware of the graph. Okay, so next edge is 1 to 2. 1 is connected to 2 and 2 is connected to 1. 1 is connected to 3 and 3 is connected to 1. 3 is connected to 4 and 4 is connected to 3. Okay, so now my adjacency is prepared. See, preparing adjacency is not a big deal. You can do it by just initializing an array of same size, array of size n, but array should be of a list. And let's say you are coding in Java, then you can just take like this, array list of integer and then array list of array of integer, and this array we can take of size 5 or let's say n in my problem. And then for every edge, let's say node u and v, there is one edge between u to v and v to u as well. Now adjacency is prepared. Now what I have to do is, it's in case Bob is not there. See, Alice is one actor and she is going from 0 root to leaf, all root to leaf path, and Bob is second guy who is going from Bob node to 0 node. Bob node will be given to us. Let's say in this problem it is 3. For now, just skip it and just consider or just focus on this Alice path. Alice path is something going from 0 to every leaf. Leaf 1, leaf 2, leaf 3. 0 to leaf, whatever is the sum, if we get the maximum sum, then maximum sum is going to be my answer. Maximum sum is going to be my answer. And the values can either be positive or negative. Let's say if I just draw this graph, it will something look like this. Yeah, graph is already drawn. In this case, 0 have a weight of -2. 1 has a score, or maybe you can say amount of 4. 2 has an amount of 2. 3 has an amount of -4. And 6 has an amount of 4 has an amount of 6. Okay, so this is the amount associated with every single node. In this case, if you are trying to find a path, the path can look like this. Then from 0 till this can be one path. And in this path, what is the score? -2 plus 4 minus 4 plus 6. Ultimately it is 4. And what about the second path? Second path is this one, -2 plus 4 plus 2, which is 6 in number, 6 in the case. Okay, but this is when Bob is not considered into picture. Let's ignore the Bob and see how we are going to do it. If I just tell you that you have to find me all root to leaf path in this graph, how you're going to do so? You should be doing with DFS, and DFS you can start from node 0, and whenever there is a leaf node, and what is a leaf node here? Leaf node is something which node is not going to some other node. See, 0 is my start node, so I am not considering 0 as a leaf node. Apart from 0, what are the other nodes with 1 edges? 4 and 2. In this case, this 4 and this 2. This 1 is also having a single node, single neighbor, but yeah, this is a source. So we are starting from 0, and 1 is having multiple edges, multiple nodes connected to it. So 2 and 4 will be my leaf node. So leaf 1 and leaf 2. And path from 0 to 2 is my one option, and 0 to 4 is my second option. And whatever is the maximum score you are getting, then that is going to be your answer. But see, in this case, if we take effect of Bob traversal, they are saying that both Bob and Alice are starting from index 0 and index Bob respectively. If I just draw the graph again, now this is my graph, and in this case Alice is starting from node 0 and Bob is starting from node 3. See, they are starting at time 0. At every 1 unit of time extra, they are just moving to the neighbor. Okay, so initially Alice at 2 and Bob at -4. So yeah, Alice will collect -2, Bob will collect -4, Bob will pay -4, and after 1 unit of time Alice is at 1 and Bob is also at 1. See, if both are at a node, then they have to make it a division. They have to divide the score accordingly. If it is 4, it should be divided as 2 and 2. If it is -4, divide at to -2 and -2. But after one more unit, now B will come to 0 and A will come to 3. But here, this score is already collected by B, and this -2 score is already collected by A. In this case, we are not going to collect it. Okay, so you understood, right? So this score can only be connected once. So that's why when Bob is also making a path, that is going to hamper our path, like our maximum cost calculation, maximum score calculation for some root to leaf path. Because let's say Bob is traversing from B to 0 and Bob is this one. Bob is traversing from B to 0. Let's say in this case I'm just drawing it again. Okay, let's say Bob is doing the traversal. Bob is starting at 0 and Alice is starting at 0. After 1 unit of time, Bob is at here and Bob have consumed this -4, and Alice is also here. Alice has consumed this -2. So if I just write the score, score of Alice and score of Bob, and time is equal to 0. At time equal to 0, after time equal to 0, Alice has collected -2 and Bob has collected -4. At time equal to 1, they both are at the same node. It means they are going to divide it half and half. So dividing it half, at time equal to 2, time equal to 2, Alice is at 3 and Bob is at 0, but now they won't be able to collect any node, right? Alice is starting from here and Bob is starting from here. Till this moment, when they are meeting, they are dividing it half and half. Otherwise, all of this portion is collected by Alice, all of this portion is collected by Bob. Okay, this is something you have to understand. And why I am telling you this? it means that in this case, if I just directly again check the path sum, initially this path sum was what was the path sum? This path sum was 4. You can check again. -2, -4, 4 and 6. It is 4. But now after the Bob is also into the picture, Bob has collected this -4 score and Bob has collected half portion of this score. Now the score will be -2 +2 and 6. 6. Now because of Bob we are getting a better score. So yeah, Bob is going to affect the sum. So in this case, how do we take care of the effect from Bob? See, as far as we have discussed that first of all we have to prepare the adjacency list. That is the first thing we do when we get a graph in the form of edges, preparing adjacency. The second thing is, let's say we are skipping the second thing. Third thing is root to leaf, maximum path from root to leaf for Alice, right? And this is something we have to prepare. But before, along with that, Bob is also going to form a path. Bob is going to form a path from node Bob to 0, and this path might hamper this maximum path. So how do we take care of this effect in our picture? What we are going to do is, see, at time equal to 0, they are collecting the points. At time equal to 1, they are collecting the points. At time equal to 2, they are collecting these points, right? So if we know, if we are starting from node 0, from Alice, if Alice is starting at node 0, Alice will already be knowing that at what time Bob will be able to reach to this location. At node 0, Alice is reaching at time 0 and Bob is reaching at time 2. So this score will be collected by Alice. And at 1, time is 1 in both the cases. Alice is reaching at time 1, Bob is also reaching at time 1, it means we have to divide it. Otherwise at 3, Alice is reaching at time 2, Bob is reaching at time 0. So yeah, Alice won't get any score in this case. So now what we have to take care of is, first of all the nodes, let's say 0, 1, 3, all the nodes traveled by Bob and at what time Bob has traveled the node. So if I maintain a map of integer, first integer is going to tell me the node, which node Bob has visited, and second one is going to tell me the time. Bob has visited node 3 at time 0, like this. Okay, so if we are able to prepare this, we can decide accordingly that whether Alice is going to accept this score, get this score or not. So in this case, this time is 0, less than 2, so Alice will get this score. And in this case, that both the time are same, so Alice will get half the score. At this time, Alice time is more than the Bob time, so it means it is already collected by Bob. So yeah, according to these three conditions, we can maintain the score of Alice. So before calculating the score for Alice, firstly we have to prepare this map. At what time, like which node is visited by Bob at what time. So this is something we have to prepare in advance. And see, how can we prepare that? See, Bob 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Bob is at 3. and Bob has to reach to 0. Starting from 3, Bob has to reach to 0. Just start a DFS call in all the direction. DFS call in all the direction, and whenever you are reaching at 0, just maintain that map. Okay. So see, recursive thinking is more important in this case. So recursion we can use because Bob has to start at 3, and from 3 it has two options, either go to 4 or go to 1. And go to 1 we have the same problem, that starting from 1 we have to go to node number 0. Yeah, that is our sub problem. So starting from 3, go to 0. So first of all, it can go something like this. Let's say it is going something like this and then going till 0. But there might be the possibility that from 3 it is going to 4. 4 it is not reaching the solution, then returning back, and then again check this possibility. This possibility is also not landing to 0. Go back and then check again. It is 0. Now in this case, yeah, it's working fine. And now I will just return from the code. Whenever I encounter 0, it means I have found the path, because from Bob node till 0 node there is only one path, and if we have found that path, then just capture the value in the map, which node is being visited at what time, because this map can be useful to process route to leaf path by Alice. Okay, so preparing adjacency is done. I will just make a DFS call starting from Bob node till 0, and I will just going to capture the data in this map, and this map will be used when I'm capturing route to leaf path in A. And how do we find the route to leaf path? Root is 0 for sure, and leaf is something. Leaf, I already told you that leaf is something, node with one neighbor. Node with one neighbor is leaf. 0 is also having one neighbor, but yes, we are starting from 0. 0 is our source. So if it is source, it is not a leaf. So that also we can find using DFS. So in this case, our algorithm will look like this. First of all, prepare the adjacency. Second one is what is the path of Bob. Let's say Bob path is something I'm calling, and in the Bob path method, what I need to pass? I can pass the starting node of Bob path, and starting this starting node till the 0 node, we'll just do the DFS and capture that in a map. And the map, you can say that map name is also Bob path, integer comma integer, it will be filled. And the third one is Alice. Let's say the function name itself is Alice. It means finding 0 to leaf, all the path from 0 to leaf. So Alice is definitely going to start from node 0. Okay, let's say starting from node 0. And what else? We also need to capture the time. So in this case also we need to capture the time, starting from 0 time. Starting from 0 time, this is time, this is node, and what else? The score also I need to capture, and score is also in the starting, it is 0. And apart from that, all the variables I can keep as a global variable, and I just have to implement these 3 functions. Then I will get my answer. And see, preparing adjacency takes order of n time, number of nodes, number of edges we are visiting, and edges are n-1 in number. And what about Bob path? Bob path is something going from Bob node to 0. In the worst case, it can go till order of n iteration, and order of n number of times the recursion calls will go. It means we are visiting every node only once. And or you can say we are already taking visited array, because this is a graph, and in the graph it's a bidirectional edges, it's an undirected graph. So yeah, we need to take care of the thing that what are all the nodes visited in the current DFS. So this is again we can do using DFS, and it will also take order of n time, going from node till leaf. Okay, that is on order of n time. In the conclusion, we can solve this problem in order of n time and in order of n space. Why space? Because there we might be taking a visited array as well, or recursion tree. Now let me show you the code for this approach. Now this is the code of my approach. First of all, the first step is preparing the adjacency list, and then for the adjacency list we are given edges, and for every edge I have taken an array of array list. An array of array list is going to be of size n, and initialize it with empty array list, and then added all the edges from u to v and v to u. Okay, and this is just a logic to prepare the adjacency list if number of edges and number of nodes are given. After that we have to prepare the path of Bob, and the path of Bob is something what node is visited at what time. Okay, and after that, like I am just doing one more DFS call to find the path of Alice from source to destination. See, if we have a look on the Bob path is something going from node Bob to 0, right? If we have encountered 0, it means we have found the path. Otherwise, make subsequent call to the neighbors. See, I started with, let's say, if I just take an example, I started with index 3, node 3. I started with node 3, and then first of all mark it visited. Every node will be visited only once, so you have to mark it visited and then put it in the map, and then see whether you have reached the target node, which is source. If that is the case, just return true. It means you don't have to go further. Otherwise, just call the neighbors, and if even after calling the neighbors you are not getting the answer, it means you have to return false from that case, and you have to just remove it, doing the backtracking. See, this is the recursion to be able to get the map, and after that, once the map is ready, we will be using that map to prepare the Alice path. And Alice path is something starting from node 0 and starting at time 0. Income is something my temporary variable, so whenever I reach to the leaf node, I will just check the maximum value of income. First of all, mark the node visited. Okay, marking node visited, I will capture the value of income. And how do I capture it? See, the value of income will be captured on the basis of Bob path. If Bob has already visited that node, it means I'm not going to capture it. So only two cases are there. If Alice is picking the node, or Alice and Bob are reaching the node same time. So this 0 node will be picked by Alice. It means the time the Alice is reaching the node is less than the time Bob is reaching the node. Okay, and definitely Bob should have visited that node. So in this case, Alice will capture the whole value. Otherwise, else if the time is same, then it will be divided. Otherwise, no income is there, so there is no condition. And this is my corner case. Corner case is something when I am reaching the source, not source, reaching the leaf node. Leaf node is something where the neighboring nodes are 1 in number. It means only one neighbor is there. But we have to avoid 0 because 0 is our source node. Then capture the maximum one, and otherwise keep doing this DFS for every unvisited neighbor. This is something we have to do. Doing 2 DFS calls. First one to store the map for Bob, and second one to find the path, maximum path, using this Bob path in consideration. Okay, and the time complexity of this approach will be order of n. And this code will be working fine. I'm submitting the code. I submitted successfully. I hope you understood the approach. In case you get any doubt, you can comment down below. I understand that it's a medium to hard problem, so maybe you might face some trouble understanding the code. So just do the couple of dry run on the sample examples given in the problem statement, maybe this example 1 or example 2, then you will get some more clarity. Thank you guys, bye bye.